What else do we look for? Events, right? Events could be both computer level events, right, such as someone pressing the key on the keyboard and you want to be able to recognize it as an event. But typically this is just sort of like a method call, right? So pressing a key on the keyboard does not necessarily represent, you know, an entity or object of some sort. However, in your initial response to someone pressing the key, okay, you could create an object and place it in some sort of queue, which will be sitting in that queue until other part of the system will retrieve that thing from the queue and process it, right? So you can transition from just a signal that tells you there's a key pressed on the keyboard. You can transition internally into creation of an object, placing it in some sort of like a queue-like container and having it serviced at some point down the road. Okay. And by the way, the simplest version of that processing may be that it can be just discarded, right? Because sometimes you may decide that keystroke is irrelevant and useless in the situation that you're dealing with, and you can just dispose of it, and that's all processing that you may be doing with that. And in other cases, of course, it'll be different. But other set of events in the system could be, again, going back to the application domain, basically, right? And let me clean up this set of demonstrations which were not relevant to our real estate management system. Okay, over here, if you have something like a sale, right? You have a sale. This could be used as an event, right? Or closing event, right? That is relevant. Property closing. Obviously, the situation where certain parties gather and make a decision that this is going to be final now, right? So you can have a pending sale and then finalize it at some point by closing it. So both can qualify, sale is more of a transactional type of object, whereas the closing then becomes sort of like an event in the life cycle of that transaction, right? So again, it all is really specific to your application domain, to your problem, to the problem that you're trying to solve. But again, categorization and recognition of the role of each class or object in your system is sort of like important because it impacts on the priorities and things. Okay, so here's next question. Sometimes it's difficult to make a decision about a class or attribute. Like for instance, if you have this piece of data which is pretty tangible, you understand it's very important to your system, but should it be its own class of objects, or should it become your just an attribute, part of another class? So let's think about it. So like I said, difficult to decide sometimes, right? Whether some information should be modeled as attribute or separate entity, separate class. Okay. So what things to consider here? So a couple of tips here. If information always is handled separately as one entity, it should be modeled as an entity. Okay, we need an example, right? We need an example. An example here may be this address over here, okay? I have this address class, and it has, let me think about, the typical attributes like street, right? Street, town, right? Town or city, state, then the zip code, and things like that, right? So on the surface, this is all pretty pretty straightforward, should not be a huge problem or decision making. However, all of a sudden you begin to realize that there could be a lot of things going on with the zip code. All right, you can store it as an integer, you can store it as a string, right? Or you can go even further. Maybe if you want to realize that your post office wants to use like zip +4, right? So zip codes that are written like n dash n, things like that. So all of a sudden this becomes more of a more sophisticated data structure, right? So perhaps you may decide that sometimes you don't know what the zip +4 formula is. Sometimes you do know. Sometimes you want to have your postal service contribute those. You can do other things with zip codes. You can tie them to your property or land parcel GPS location. You may also want to decide about the zip codes versus states, right? The state boundaries. For instance, you may want to ask the system, is this zip code area is on the boundary between the two states, or is it completely enclosed? Other aspects of zip codes is that some of them are just PO boxes, right? So a certain PO box could be given to a certain zip code and things like that. Sometimes in places like Manhattan in New York, certain buildings may have their separate zip codes. Like, for instance, this Empire State Building has a separate zip code, right? So all kinds of interesting things that all of a sudden going on, and this goes far beyond the integer or string representation of a zip code, right? So again, depends on your situation, the problem that you're trying to solve. You say, how much responsibility does that zip code carry in my system? Is it enough for me to just store a string or a number as an attribute, or should it be this much sophisticated? Then of course it becomes a separate entity, because it can have, as soon as I begin to see those things, and as soon as I begin to see that the zip codes can be updated separately, perhaps in your address class, instead of storing the zip code as a number or string, you can have a zip class, right, or zip +4, or whatever you decide to name it, and model the zip code as a separate class, and simply have these associated. And of course, over here in your zip field, what you do, you store a reference to another class, right? Again, but this can be an over-design or over-engineering for your problem domain, and then you may say, I don't want to do it this way, right? Or otherwise, you can say that in this version of the system, we'll just store it as an integer, but in the future, in the next version of the system, it may become a separate class, right? So all of these, extremes and everything in between can be your case. So that's where this attribute versus entity is an example of this type of decision making. All right, so there's one more tip on the screen. Information which is strongly coupled to other information and never used separately should be modeled as an attribute, right? So again, examples of attributes here, for instance, with this, like, GPS location. I don't know, whatever you store the GPS location, like latitude and longitude, and so that is very unlikely to be used anywhere else in your application. So it's sort of like belongs to the sparsal land, and clearly is a pure attribute. You just don't want to design a separate separate class. Or maybe you can design a separate class which is GPS location, which allows you to interface with your physical map or whatever, right? So again, depends, but typically if you sense that the piece of data is always used with that sort of object, it's just an attribute. You don't have to worry about making it a class. And another tip is that unless you have a very clear sense, a very clear feel that that should be, an attribute with its own specific set of behaviors, if you just feel like it's just a piece of data, it should be data attribute in one of your objects, and eventually it could develop into a separate class, but not prematurely. You don't want to do it too early. You want to holding it as an attribute, and then eventually it could become a separate class. All right, so it's time for us to move to a different room.